All right, we're back. We're on page 2, notes 12, Calc C. We're talking about arc length of a function. And so we just derived the formula, but let's make sure you know it. So if f prime, oh, that's not a laser pointer. If f prime exists and is continuous on the interval from a to b, so like it's almost always the case, there aren't really a lot of trick questions that you run into, then the arc length, lowercase s, because capital S will be surface area, of the graph of y equals f of x over the interval from a to b is given by the integral from a to b square root of 1 plus the derivative squared. So it's square root of 1 plus the derivative squared comes from the distance formula, the Pythagorean theorem, however you want to remember it. I recommend that you just memorize this for sure because the problems tend to be very straightforward and you just kind of look at them and you're like, oh, it's arc length. Also, they're almost always just set up but do not evaluate. So as far as the AP exam is concerned, yeah, it'll be like cleverly written problems where like usually a tree identity or you get a perfect square inside the radical and it like takes care of itself. Or it'll be calculator, or it'll just be multiple choice where you select the correct integral. In my experience, it'll probably be that. So let's see if we can do a couple. So approximate to 3 decimals, nice. The length of the hyperbola y, x, y equals 1. From the point 1, 1 to the point 2, comma 1 half, show your setup. All right, so first of all, I need a function. So I'm going to say y equals 1 over x, which means that dy dx is negative 1 over x squared. And so all we're really doing here is the integral from, so 1 to 2, right? X value to x value, square root, bad square root, 1 plus negative 1 over x squared, squared, dx. All right. And then it's to 3 decimals, so I guess we will be using a calculator for that. So let's share. I'm trying to remember like shortcuts. Nope, wrong. What do you mean? I was pretty sure that was the, oh, because I'm already sharing. So that doesn't, look at that. That shortcut does not work if you're already sharing your screen. So that's something to know. New, here, I'm just gonna do integral from 1 to 2 of the square root. I don't know why I'm pressing all the buttons right now, but I am. 1 plus negative 1 over x squared dx and 3 decimals. So 1.132. So approximately 1.132. All right, let's go back to the notes and see what the next problem is. Let's do it. Get back to the notes. I wish it was faster at switching. That would in the course of my life have saved me a lot of time. I've done a lot of switching at this point. All right, find the exact, okay, exact value. So this must be clever somehow, because if you can find the exact value, something magical must happen. Arc length of this thing from 0 to pi over 4. All right, so let's see. We need dy dx. So f prime of x is going to be 1 over cosine times the derivative of cosine. So negative sine over cosine. Okay, so that's negative tangent. And so what we want to do is the integral from 0 to pi over 4 of the square root of 1 plus negative tan of x. I'm writing really big, probably going to regret that. Okay, so 0 to pi over 4, square root of 1 plus tan squared. 1 plus tan squared, that's Pythagorean identity. So we're in shape, maybe 0 to pi over 4, square root of secant squared. So like you always have to kind of worry like, oh, is it always positive on the interval or whatever? But like, I'm here to tell you that arc length problems, other than like, I'm sure there are trick questions out there, they work out. So like, this is technically the absolute value, but between 0 and pi over 4, secant is definitely positive. Think about the graph of cosine. Between 0 and pi over 4, cosine is positive. So this will work out. So this is the integral from 0 to pi over 4 of just normal secant. And then you do the trick where you multiply by secant plus tan over secant plus tan, and this becomes, also just memorize it, natural log, absolute value, secant plus tan, ugh. And then it's a definite integral, 0 to pi over 4. So now we got to remember secants and tangents of these. Natural log. All right. The secant of pi over 4 is radical 2. The tangent is 1 minus the natural log. The secant of 0 is 1, and the tangent is 0. So we just get natural log square root of 2 plus 1. That seems okay to me. So the next one is to approximate. So I'm just going to set it up, and then I'll check the one we just did and get this approximation at the same time. So f prime setup is like, come on, cosine. So we want the integral from 0 to pi square root 1 plus cosine squared. It's a 1 plus cosine squared. So if it was 1 minus cosine squared, we would have options, right? It could make that sine squared and then go from there. 1 plus though, there's not really a thing. All right, so we're checking the one above it, and we're going to get the answer to this one. So to the calculator. So let's see. I want to do the integral of the square root of 1 plus tangent of x squared comma x, and we're going from 0 to pi over 4. It's always like, I press enter and I just hope. All right, yes, good. Integral of square root 1 plus cosine of x squared. X is our variable, 0 to pi. I'm gonna do control enter to get, well, I don't know what this will do. Yeah, you don't even need control enter because I can't do it anyway. So 0.3820, I'm gonna write 3.820. 3.820. And that's it. There's like not too much going on. There is a built-in function. So like if you are allowed to use your calculator, arc length is an option. I like don't actually know the syntax for this. It's probably like the function. I'm gonna say the variable and then where to start and where to stop. Yeah. So if you're allowed to use a calculator after you've set it up. So the key is that you still have to set it up. So make sure you know what to do. But this can, will it get the exact value? I mean, probably, because like, I don't know what it's even doing. It's probably just doing what we did. Yeah, nice. Okay. So feel free to use that when you're checking, or if you're just allowed to use a calculator. It's really about setting up and showing that you know that stuff. So go back to the notes, and then I will wrap this one up, and I will see you in the next video, where if I had to guess, I would say we're just going to do more because there's not really more to the concept of arc length. So let's see what we got. So see you there.